Hi, I'm Ramya, Embedded Software Engineer at Microsoft Technologies. Welcome to this tutorial where we will build a water level monitoring system using TDCA, which is Target Device Communication Interface, with Arduino. This project helps monitor the water level in tanks and ensuring efficient management of water resources. So, let's see what is TDCA. TDCA facilitates seamless communication between a host and target monitor. So here the target hardware will be Arduino or Cortex anything. We are using Arduino here. So it allows us to send commands from the host and receive the real-time data from the target monitor. And this making it a perfect for monitoring applications like our water level system. So let's see the overview of this project. Our water level monitoring system consists of a water level sensor to measure the water depth, an Arduino board to process the data, and TDCA for communication with the host PC. This setup allows us to monitor water levels accurately. Okay, now let's see what are the components we are using here. Number one is ultrasonic sensor, which is used to measure the level of water. So using the sensor, I'm going to measure the level in the water tank. And then Arduino Uno, which is the target board of our project. And then DC motor. This is the motor. We can just consider that this is the motor we are running for filling the water tanks. And then buzzer. Buzzer is for alarming the people to indicate that water tank is filled. So these are the four major components we are using in this project. Let's see how the system is working. Ultrasonic sensors are positioned above the water tank to measure the distance of the water surface. As the water level rises or falls, the distance changes, allowing the system to calculate the current water level. So the control logic for monitoring the water levels is simulated on the RTOS running on a host machine, which allows developers to test and refine the system before deployment. So now we will configure this TDCA part, and the Arduino actually reads the water level data from this ultrasonic sensor. When the water level crosses the predefined threshold, as we set on the ultrasonic sensor, it sends the alert to the host PC through this TDCA via serial communication. So indicating whether the tank is full, empty, or at an optimal level. So as the sensor measure the water level, the Arduino processes this data and sends to the host PC using TDCA. The host PC can display the information or monitor the water level in real time. So here the system, as the water level rise or falls, the sensor detects the changes, and then the Arduino processing data and communicate with the host PC and updating the status of the water level. Everything is in real time. So this is how we achieve the ARTAS concepts here. Okay, now let's see the coding part. Okay, coming to this coding part, we should add this TDCA.h, which is necessary to use the TDCA APIs. And coming to the OS application start main function, here we should must initialize this TDCA. So this is the one making communication between host and target, and you should use your compute number, and this is the one making the serial connection and giving you the hardware details, and then handling each command through mutex concept. So don't forget to initialize the TDCA init at first of the code. Okay, and the following will be the as usual Arduino code. Now I'm going to run this one. Okay. So here you can see each command is sent by the host side and the relevant response is coming from the Arduino side. So it depends on my code. Line by line, each API is executing and we are getting a response status. And you can also see for each status the mutex is coming. So that is handling the command without making any collision or unexpected error. So you can see the pulse in also. You see here the param value. This is showing the ultrasonic sensor value, and it is a calculated distance. When I'm not detecting the sensor, I'm getting a large value. So that is saying water is empty. And similarly, when I'm trying to detect the sensor, then the sensor value will be less and the calculated distance is showing. And now it is saying water is full, and that time the buzzer will also glow. So based on this project, we can able to alert the system of people that the water tank is full or empty. So based on the alert system or indication system, we can use this project. Okay, coming to see the hardware setup next. This is my hardware setup of water level monitoring system, Arduino Uno board, and ultrasonic sensor, motor, and then buzzer for alarming purpose. So I gave all the required connection to the sensor, motor, and the buzzer. So now I'm going to just reset to make sure the system works properly, and now I'm going to run this project. So now I started running this project. So you can see my initially my motor is running, so which means my tank is going to fill by running this motor. So this ultrasonic sensor, now I am not detecting anything, which means water level is empty. So when if I detect this, then water level is filled. So in this condition, my alarm is not alerting people that because the tank is empty. When I am trying to detect this ultrasonic sensor, you can see my buzzer is alarming and motor got stopped. So when I am trying to just remove the distance from far away, then you can see my buzzer is stopped alarming and my motor is started running, so which means the tank is again empty. So using this ultrasonic sensor, we can measure the level of the water, so that we can fix when the level of water very closer to this ultrasonic sensor, then the motor will automatically stop and then buzzer will started alarming. So this system is very helpful to managing the water level monitoring system in the tanks. So this is how TDCI helps to make this ATAS based water level monitoring system useful to the people. So that's it. Thanks for tuning in. If you found this helpful, stay connected for more ATAS related videos. Bye.